Benvenuti a tutti i nostri telespettatori. Siamo qua in questa serata intitolata Innovation and Research. Io sono David Fiorentini, il vicepresidente dell'UGEI, dell'Unione Giovani Ebrei d'Italia, e responsabile del desk Israele per Attikva. Abbiamo con noi collegati stasera il nostro consigliere dell'UGEI Giulio Piperno e la professoressa da Israele Michal Beeri. Adesso passo la parola un attimo a Giulio giusto per presentarsi e dare un breve indirizzo di saluto. Vai Giulio.
Sono Giulio, sono un dottorando in neuroscienze cognitive, quindi ero molto attratto dalla tematica di stasera perché quello è l'ambito di cui mi occupo e parteciperò poi dopo la discussione, dopo il talk con la professoressa. And now I think we can give the talk to Professor that is going to give us a talk on Alzheimer and new approach to treat it.
All right, very good. So I'm going to try to say my effort in Italian for a moment. And here I go. Grazie mille per l'invito per parlare della nostra ricerca sull'Alzheimer. I got it?
Amazing.
Bravissima.
All right. So since I understand there are many people from different expertises or students in different areas, I'm going to keep the conversation on a more lay people level, but of course I'm very happy to answer questions. And since this is relatively informal, if people want to ask questions while I'm talking, then I'm more than happy to answer. So I'm going to focus on work we're doing here at the Sheba Medical Center, and this is why I called it how can the startup country truly help in developing solutions for the prevention of Alzheimer's disease. So I'm just to concretize, for those who are not familiar, and unfortunately I believe that most of you will be familiar with how Alzheimer's disease looks because it's at this time of existence, there is almost nobody who doesn't know someone who has Alzheimer's. When I present this to older adults, their reactions are very different than when they're for young people. But if I say not too long ago, I had to give a presentation before COVID for 800 older adults in something called Shabbat Tarbut, which is a morning that people come to listen to different professionals speak. By the way, that was the day that Yair Lapid gave a presentation, so I was sure that I would be less interesting than him, and the news are that I was more interesting than him. Politicians are very boring. In any case, so I asked 800 people if there is anybody in the audience that never forgets names, okay? Remember, those are older adults. And there was like a ha ha ha, people laughing, and one guy raised his hand. And my message in those situations is when we're looking at Alzheimer's disease, we're looking at true disease, forgetting names, forgetting where you put your keys, forgetting where you put your eyeglasses, are not concerning memory complaints. We're looking for things that are significant, that affect functioning, and I'll show you in a moment how we diagnose the disease. When 800, message I try to pass is that when 800 people or 799 people out of 800 say that they sometimes at least forget names, that means that's the norm. It's an annoying norm. It's a scary norm. It makes many people say, oh my God, this is beginning to happen. I'm getting Alzheimer's disease, but it's not a concerning memory complaint. Many times people similarly, they go to the kitchen, they want to do something, they don't remember what it is, they get very nervous about it. Those are very common forgetfulnesses of older adults, and they do not reflect Alzheimer's disease. In Alzheimer's disease, you go and you don't recollect ever again what is that you're going to look for. In Alzheimer's disease, in normal aging, even in 100 years old people, we're going to expect to see some learning. And in Alzheimer's disease, there isn't learning, okay? So it's something that is much deeper than the typical subjective memory complaint that older adults have. So generally speaking, or simplistically speaking, we diagnose the disease as a disease of memory problems that have to be objectively assessed, okay? So people who come to us, I'm forgetting names and I don't remember where I put my wallet, I'm actually happy about when we discuss those kind of patients, and you know, the summary of the neuropsychological testing of the patient is that he has a lot of concern about his forgetfulness about names or similar. I am actually happy. We look for objective memory impairment and at least one more cognitive impairment. It can be in perception, in orientation in time, orientation in space, in speech fluency, in executive functions, right, which are the higher functions of what separates us from animals mostly, right, is our capacity of making decisions, capacity of understanding sense of humor, capacity of being flexible when we're thinking about a complex situation or complex thought. So as concrete examples, people may come to us and say he can't even make a decision of what to have for breakfast. And this is not because that person doesn't want to make the decision, it's because his pathology in the brain is affecting areas that are incapacitating him or her from making a simple decision as what to eat for breakfast. We do expect to see a clear deterioration compared to the original state. So I always give an example, which is just simply a good example of a participant of mine. I work in Sheba, right? And I work also at Mount Sinai in New York. This is where my faculty position is. So I share my time. And if it's not COVID times, I keep traveling back and forth, which is kind of nice. And so I had a patient there who was 94 years old, was still driving, very, very fine lady. And once she came to the assessment, to the research assessment, she came late and I asked what happened. And she said she got lost. And I got a little nervous about it. And I said, what do you mean you got lost? And she said, don't worry about it. I have been a lost soul since ever. My orientation in space is terrible. And then I calm down because what I'm expecting to see is the kind of sentences that families say, like, if you only knew who she was 10 years ago, or if you had only known what impeccable memory he had, sentences that clinically make you feel very strongly that that person had a significant deterioration compared to a prior state. And we do expect impairment in social, professional, and day-to-day functioning. And the professional issue became kind of interesting. My mom is 78 and a half, and she still works full-time job, something that 20 years ago or 15 years ago never happened, or happened very, very rarely. So people, they finish working, women typically at 60, men typically at the age of 65, and that was it. They went to do something else. Today, people are tending to work sometimes until the very end of their lives. In New York, we have a family of 4 siblings. They're Ashkenazi Jews, so they're studied by so many groups. And the older is 103, then 101, and then 99 and 98. And the 98 years old dude, he is a lawyer that works in the same firm as his son, grandson, and great-grandson. It's 4 generations working in the same place. And this 98 years old person is cognitively normal and continues being functional. Today, because older adults do continue working, many times the first complaints to the family, who still doesn't see much, is through the coworkers that see, let's say, a messy desk that wasn't what it was before, or forgetting meetings, or being inappropriate in meetings, something that at home the person is able to handle, but at work, because the request of the mental effort is higher, it might show up as a symptom. And finally, we want to make sure it's not something else, what we call a differential diagnosis. We want to make sure that it's not a severe B12 deficiency, that it's not a stroke, that it's not a tumor in the brain, etc. Okay, so it's a formal diagnosis that many times people say, oh, it's easy, if he's forgetting, then he's demented, and that is not true. This graph is probably my main motivation to do what I'm doing. And it's an old graph, but the trends are not changing very much. There are tiny little changes in trends in developed countries, but in developing countries, the numbers are actually getting worse. So generally speaking, the green is Alzheimer's disease, the purple is any other dementia. And maybe I should take a minute for those who are not familiar with those concepts. Many times people get confused between dementia and Alzheimer's disease. And worse than that, many times families think that Alzheimer's disease, stereotypically speaking, is very bad and dementia is less bad. So they'll say, oh, my dad doesn't have Alzheimer's disease, he has dementia. All right, so dementia is an umbrella name for symptoms, for a clinical picture that looks like what I just described to you before. Very typically, an impairment in memory and then impairment in other cognitive domains that go and deteriorate over time until the person is not able to function independently anymore. Some of those, so this is an umbrella name. Under this umbrella name, there are several types of dementia. If you take 100 people with dementia, 70% of them or so will have Alzheimer's disease dementia. The definition is pathological, all right? So they will have some type, primarily two main definitions, biological definitions of Alzheimer's in the brain, or two neurobiological markers. One of them is called amyloid, and the other is called tau. Amyloid is a protein that aggregates between the neurons, between the brain cells, simplistically speaking, okay? And tau is a protein that supposedly holds the body of a neuron in a specific shape. And when it deteriorates, degrades, malfunctions, then the shape collapses and the cell eventually dies. So amyloid is out of the cell and tau is inside the body of the cell. So as I was saying, 70% of the people who have some type of dementia will have Alzheimer's in the brain, Alzheimer's pathology. And then about 15% will have primarily cerebrovascular disease, so vessel disease in the brain, which keeps aggregating and aggregating to the point that the person begins to deteriorate. And then smaller numbers of more rare dementias, frontotemporal dementia, people with Parkinson's disease, a reasonable proportion of them will develop dementia. There is AIDS dementia, there is alcoholism dementia, and so on. What I'm showing you here is, so you look at the graph as a whole, okay, we'll look at his dementia. What you see here is that between the ages of 65 to 69, you'll have, let's say, about 5, 6, 7% of the population, depending where, that will have dementia. And if we jump to 85 to 89, it's about 50%, okay? So when I say this is my major motivator is that the oldest old, those who are above the age of 90, they are at the highest risk of developing dementia, and they are the fastest growing segment of the population. And 50%, you take two, one of them will have some kind of dementia. In fact, in very old age, it becomes very difficult to separate the different kinds of dementia because the brain looks like a garden variety of pathologies. Now, in the past, we thought that if you made it to 90 and you didn't get demented, then you probably won't get demented because you're strong enough not to die. So probably you're strong enough not to have dementia. And that is not true. The numbers continue growing. And theoretically speaking, if we grow old enough, we're all going to be demented. This is not great optimism for anybody. And I'll show you at the very end of this presentation that is not always true. But the prevalence, of the disease continues growing, even in very old age. Now we have a major problem in the field. Over 460 molecules have been tested for treating Alzheimer's disease in the last 10 to 12 years, and none have worked. All right, I'm going to put in parentheses one medication that is called aducanumab, that is supposedly breaking down amyloid, that is being now considered by the FDA. If anybody wants to ask a specific question about this medication, we can discuss it at the end. But otherwise, There are 4 medications in the market. They don't change the course of the disease. What that means is that a person is declining. They treat for a little while, they get some of the symptoms a little better. And then at some point, a person goes back to the same rate of decline the person was before, okay? So they're not very successful. And another problem that we have the medications that are in the field or now in the market is that 30 to 40% of the patients react to them. The other 60 to 70% actually it doesn't affect them beneficially. The problem is that we haven't been able to discover what characterizes the people that react well to the medication. So it's not sex, and it's not genetics, as far as we know, and it's not age, and it's not a bunch of other things. So the general solution is that we treat, right, the doctors treat everybody in order to have the chance of maybe improving a little bit the symptoms of some of them. So then again, since those 4 medications have been out of the market, another 460 came out with tests, clinical trials with no success. This is just to give you a feel, okay? Just a feel of the different pathologies that the world is working on to address or to treat Alzheimer's disease. This is an amyloid plaque. So the plaques aggregate and they form a plaque. And this is a real brain from our brain bank in Mount Sinai. And those are the tangles. Tangles are the ultimate shape of this tau protein that I mentioned before, that when the cell collapses, it ends up looking like this little fish. This is also real human brain. And this is actually here from our lab here that was donated, by the way, by a family from Milano. And this is a microglia. Microglia is like, now everybody knows what a T cell is, right? Or microglia is like the immune system of the brain. And in normal conditions, which is this example, it knows how to chop in amyloid, which is whatever orange color little patches here. So you can see this microglia was very effective and chopped a lot of amyloid into it. And in Alzheimer's disease, something happens with this activation that it becomes dysfunctional. And part of the pathology seems to be aggregating because the microglia can't take it in. And acetylcholine, for those who are not familiar with the expression, the brain has many different kinds of chemicals, and one of them is acetylcholine, and it's the first one to be decreased in Alzheimer's disease. So those medications that I mentioned before that are in the market, what they do is to increase the levels of acetylcholine in the brain, in the synapse, which is here in between 2 neurons. And but as I said, this line of treatment is a little bit helpful, but it does not change the course of disease. And then there are other areas that medications are being developed for in between neurons. There are chemicals that activate the next neuron, that depress the prior neuron. There's a lot of communication in between neurons. In those chemicals, some of them go down in Alzheimer's disease. So there are now medications trying to increase the levels of those synaptic proteins, they're called. And there is a lot of literature on insulin in the brain, an area that I have particular interest in. So the next question is, why? Why are we failing? All right. For us who are ricercatori in the field, it's horrible. All right. I've been 20 years in this field. Every day of my life, I'm devoting to find something to help someone who is about to develop Alzheimer's, has developed it. Why are we failing? So there are a gazillion reasons, and I'm going to focus on 3 of them, just both because we don't have time and I want to show you a bunch of things, but also because I want to try to simplify and get to what I think is our main reasons for why the medications don't work. One reason is genetic heterogeneity, all right? And what I mean by that is, take, for example, breast cancer. Okay, it's always a good example. Today, I believe there is something like 75 or 76 different treatment protocols for breast cancer, and most of them are personalized to the patient according to her genetic background. Why on earth would we think that in the brain, genetic heterogeneity doesn't make a difference. Remember, there is nothing in the universe that gets even close to the complexity of the brain. And yet when we run clinical trials for Alzheimer's disease, we take 3,000 Alzheimer's disease that will be on a medication and 3,000 Alzheimer's disease patients that will be on placebo with no relation to the genetic background. And we do know there is a genetic component in Alzheimer's disease. So this is one major issue, and it's an issue that is being treated. One of the reasons why primarily pharmaceutical companies, I mean, the main, let's say, fair reason not to deal with genetic heterogeneity is because we have this little hope that we'll find the pill that will help everybody. And that's something we all want, all right? I think it's unrealistic. The second reason is a reason that is more business reason, therefore I think it's unfair, which is I think the pharmaceutical companies, with all the good intentions that they might have in the background, I think they want to make money. And if you discover that only people with a very specific genetic background react to that particular medication, you'll have a smaller market share. But honestly, I think there is no choice, and that we will have to account for genetic heterogeneity when we're running clinical trials. The second main reason is that maybe we're not hitting the right biological target, okay? There have been many, I talked a lot about amyloid, and I'm going to continue talking about it, but there have been many clinical trials addressing amyloid per se, all right? Trying to break down the pathway that builds it up into a plaque, trying to break down the plaque itself. And except for this aducanumab medication that is being discussed with many question marks by the FDA, none has worked. So one reason can be the number 3, which I'm gonna mention in a moment, which is the age that we address disease and pathology. And the other reason may be that we're addressing the wrong pathology, or that for a subgroup of people, amyloid is extremely toxic, or for other people it isn't, and then you put everybody again in one clinical trial, you get nothing. The good thing about this issue of possibly be addressing the wrong pathology is that the world opened up. Our field opened up, and I think that today everybody is considering many pathologies, many changes in proteins, many genetic changes that might be affecting and so on. Now, the third reason why we might have failed is that Alzheimer's disease pathology, primarily amyloid, but also cerebrovascular disease, disease of the vessels in the brain, begins in middle age. All right, let me show you the next slide. This line here, the dotted line, is similar to that graph of age that I showed you before. All right, so it's a bunch, you get at 60 to 65, you get, about 5% will have Alzheimer's disease or dementia. And then at 85, you get about half, all right? What you see in the hard black line is actually the pathology, the amyloid aggregation in the brain. And as you can see, this red arrow here, doubled arrow, people begin developing amyloid pathology at their 40s and 50s. If we go to treat them with an anti-amyloid medication or any medication when they're 75, when they're showing symptoms already, they have had the chance to grow a bunch of blah in their brain and a bunch of death of neurons for over 25 years, 30 years, 20 years, right? So it might well be that we're treating people so late that there is nothing to do for them. I don't like to look at things that way, because that would mean that we should give up on trying to find a medication to treat people that have Alzheimer's disease and stop their disease. I do not believe we will be able to reverse it, okay? Because when neurons die, and we can't revive them. But maybe we'll have medications to significantly slow down the disease. But what I really think is that we have to go back to the prevention phase. So let's look a little bit at risk factors for Alzheimer's disease. Age is, I showed you that first graph, age is the strongest. There is no other risk factor that is as strong as age, and I'm showing you the non-modifiable ones, okay? Sex, women are at much higher risk of having Alzheimer's disease than men. So about 2/3 of Alzheimer's disease patients are women. Sometimes people say, oh, it's because women live longer, and that's not a correct answer, because in those models where we see more women developing Alzheimer's disease, we adjust, we do statistical mumbo jumbo to take into account that women live longer. Women have more Alzheimer's disease, and there are other diseases that have sex preference, right? There are, heart disease. With time, women are getting more and more because as they smoke and and get into the stress of the working market, women have more heart disease, and yet still heart disease tends to like more men than women, and so on. And the third non-modifiable risk factor is genetics. Today, there are about 25 genes that have been recognized to be implicated in Alzheimer's disease, but none of them is as strongly related to the disease as the ApoE4 genotype. So the ApoE4 gene is strongly associated with Alzheimer's disease. If you have the 4 genotype, people can have a 2, a 3, or a 4, and you get one from mom and one from dad. So you have 2, 2, 2, 3, 2, 4, any combination of 2, 3, and 4. People who have a 4 are 3 to 4 times at higher risk of developing the disease, and people who have double 4, got a 4 from mom and from dad, then they're in very big trouble. I should emphasize, for those who might have watched Still Alice, and it's a movie that Julianne Moore acts a woman that is very bright and very beautiful, very capable. At the age of 50, she develops early onset Alzheimer's disease. Early onset Alzheimer's disease is a little different, not a little, is different than regular, quote unquote, what we call sporadic Alzheimer's disease. Early onset depends on one of 3 mutations called APP, PS1, and PS2. If a person has that mutation, either because a parent had it or because it's a de novo mutation, it just happened, that person will have Alzheimer's disease. It will most probably occur very early at the 40s, 50s, and it is hereditary. Half of the children of that person will have that kind of Alzheimer's disease. It's typically more severe, the decline is faster, and so on. What I'm talking about here is late onset or sporadic Alzheimer's disease, which is about 98% of the Alzheimer's disease cases. Now, modifiable risk factors are physical activity, obesity, hypertension, diabetes, smoking. Those are all those 5 are also risk factors for heart disease. So I always keep saying when I give presentations to older adults, I say, remember that what is good for your heart is good for your brain. So those 5 go together. And then there are 2 risk factors that are specific to the brain. One of them is cognitive activity. So there is, I don't want to say whopping literature, but I want to say enough literature suggesting that cognitive activity has a protective effect. And depression has been associated with cognitive decline and dementia in numerous studies. What we don't know about depression, and there is a long way still to go, is if it's part of the disease. So there is incipient Alzheimer's disease already happening in the brain, and the person gets depressed as one of the first symptoms. That's one option. And another option is that depression and Alzheimer's disease have similar pathologies, so they tend to happen at the same time. But in any case, the recommendation is to treat depression because first, it's bad to be depressed. It's not fun, but also because it might be affecting Alzheimer's disease. And even if it's not directly affecting, it might indirectly affect because depressed people will tend to become obese, will tend to take less good care of or being adherent to their medications and so on. So the message I'm trying to pass is, remember those 460 pills that didn't work, right? I keep saying people want a pill, people want a super pill that will resolve their dementia. And the reality is that we're not seeing this, but there are a few clinical trials that are taking people who have high risk due to those cardiovascular risk factors. And they work very hard on either taking away those risk factors or balancing them very well. And they compare them to people who are being taught about general health. Okay, so that would be the placebo. And there are a few studies suggesting that the rate of decline in people who are not being well cared for their risk factors they're declining faster, all right? Now, this is a very important finding. There are 3 such studies that have been published, and many of them are being replicated. There are problems with some of the studies, but generally speaking, when I compare the 460 pills where the results were zilch to a few studies on prevention when the results are interesting, there is still a lot of work to do, then I get very excited and I say, wait a minute, I think this may work. One of the issues that people are concerned about, and with good reason, is that a prevention study, the way we're doing it now, is not going to take away the disease, all right? So if we control well diabetes, hypertension, physical activity, blah, blah, it's not going to wipe out amyloid. And maybe, and probably, it's not going to stop amyloid from aggregating. But it seems that it has a good chance of making everything go slower. So this would change the course of disease. It's not just a blip and then going down to the same level, the same rate of decline, but it's really making it slower. Now I ask you, and I would be surprised if you answer anything, but yes, I would want it, is would you prefer to not be treated or to do a prevention program that will push your dementia 15 years away, right? There is no question mark. It's better to be demented at the age of 85 than at the age of 70, trust me. All right, just so you know, the World Health Organization didn't wait. It was surprising for me, by the way, I was surprised, but they do define a dementia prevention recommendation. So anybody who's interested in taking a look, it's a huge pack of, you know, evidence that they put together, but they have a little summary of just a few pages in which they delineate the different risk factors. They talk a lot about nutrition there. If you guys have an interest about asking about nutrition, we can talk about it at the end. I try to get out of it just because it's complex, but I can give you some information about that as well. And this is just the website of the World Health Organization. So our scientific or main scientific goal actually takes a double shape, okay? We want to find technologies that can identify the very, very early steps of the disease, and I'll explain what I mean in a moment. And in parallel, we want to know the biological changes that represent those first little changes in cognition. Why? Because if we know both of them, this is where we want to intervene in that very, very early stage, which we hypothesize it's an optimal window of opportunity. All right, and now I'm going to give a few examples. So we have developed the Alzheimer's Breakthrough Program, and we slowly are building it up. And it's exactly what I said before. We want to define the earliest biological changes of Alzheimer's disease, right? And we want to define the earliest behavioral and cognitive changes of Alzheimer's disease. Sometimes people at this point say the following: wait a minute. So you're telling me you're gonna discover that I have very, very tiny cognitive changes when I'm 42 that mean that at age of 72, I'm gonna have Alzheimer's disease. And what do I want that for if I don't have anything to do about it? So first of all, every person has the right to ask that question, right? Many times women that have the BRCA gene, they wonder if they should or should not do the, women who may have the BRCA gene, they want to know if they should or should not do the exam. Most of the time women decide to do it because they can take out, their breasts, they can treat themselves like Angelina Jolie. Well, in Alzheimer's disease, we have very little to offer right now. So I want to suggest the following. There is plenty of research to do, and we're focused on it. But with those initial clinical trials for prevention, I think it is important to know that if you're at high risk, I think that in any time in life in general, it's good to take care of those risk factors and push them away. But if you're at high risk, they become far more important. And there is a little bit of evidence suggesting that people who know they're at high risk for Alzheimer's disease, they adhere better to interventions that help them improve those risk factors. So that's a plus. The second reason is to prepare, all right? So you know that it's 30 years ahead, and yet you can make certain decisions about your life, about your financial life, etc., to ensure that if and when it comes, you're in good shape. And the third reason to know is that there are many clinical trials beginning to be performed on preclinical people, on people who are at high risk for whatever reason, but that they're asymptomatic. So if you know that you pertain to that group, then we can call you in for such a clinical trial. We do, by the way, we are possibly the only ones in the world at this moment, which is kind of scary, but we are doing amyloid imaging. So we have PET scan, and we take pictures, or we inject a material that clings to amyloid in the brain, and then amyloid shines. All right, so we have amyloid PET, and we do tell the people who are doing those tests if they're positive or negative, if they have or don't have Alzheimer's pathology in their brain. The reason why I'm saying we're the only one is that you know what, I can't say we're the only one because I'm not sure, but I know from the United States, because I work with many groups there, that we do not disclose there the results of amyloid precisely for what I said before, because we don't have a medication to give, so we prefer not to say. However, Israelis are very stubborn people, and they want to know everything. And we got into a reality that if they participate in research and we do amyloid imaging on them, and we don't tell them the answer, they won't volunteer. So we had a big discussion with our institutional review board, with our Helsinki committee, our ethics committee, and we made a decision that we will exclude from those studies people who have high levels of anxiety or high levels of depression. They cannot do this study. And then we give the answer to everybody. 3 people did not want to know, and then they changed their mind. We have done, I believe, something like 220 so far. So now I'm going to give specific examples, okay? So then again, when I say early diagnoses, we want to redefine the symptomatology. So today, as I said before, we do cognitive testing face-to-face, sometimes with a computer. People answer questions. We give them scores, and we say, oh, this score is below the norm. This score is in the norm, above the norm, and we make a decision. Those tests are not sensitive enough to catch very, very, very subtle initial changes in cognition. So by using new technologies, and I'm going to give you a few examples, we might be able to grasp something that the best doctor in the world, the best neurologists or the best psychiatrists that are experts in dementia are not able to grasp because they're very, very subtle, but technologies might be able to catch it. So this is a company we're working with, and let me just say up front, let me just see how we're doing with time, David? We
are there. I think we can go on for another 5-10 minutes.
All right, so I'll try to push it. I'll try to push it
to go towards, yes, I think 5 minutes or 10.
Okay, okay, that's fine. So this is, I should say that I have no conflict of interest with any of the technologies. I'm testing them purely and solely for research. I'm not part of the companies, no, nothing like that, okay? I just have an interest in very early diagnosis. So this is a technology, it's actually a very sophisticated camera that takes pictures of the retina. The retina is a protrusion of the brain, and it does aggregate amyloid. And this technology is trying to assess amyloid in the retina. This is an initial study, okay? We just got a Bill Gates Foundation grant to test and see if what we see with this camera in the retina is correlating to what we see in the brain. Our assumption is that yes. And the results here are just generally speaking, they're showing that people who have higher levels of what we believe is amyloid in the retina, they have a faster rate of cognitive, or they tend to be more cognitively impaired. And this is another technology we've been working with. It's called MindU, and it's a cell phone-based technology, and they use all the cell phone sensors to build up what they call a cognitive behavioral measure, all right? So they record your speech fluency, they record your reaction time, the amount of space that you use, and they build up an algorithm. And what you see here is this is very, very initial data that we have been collecting, but it's a nice correlation between the hippocampus, which is the region, the first region of the brain affected by Alzheimer's disease, and the measures of fluency that are collected by the phone. So those people were from 4 to 6 months using their phone and being recorded for all those activities that I mentioned. And we can see, at least in this very initial analysis, that your cell phone can give us information about the size of your hippocampus. And I find that obviously very exciting. Think about it clinically speaking for a moment, that theoretically, if this thing works and everybody agrees to have this app in their phone, then you have it, and this, it uses artificial intelligence, it keeps learning you. And then one day you're 61 years old and something looks a little different, and a window will open for you, for your caregiver, for your doctor, and say, there is something going on. This person is departing from normalcy. If you take a look here on your left, this is a real patient. She is an Alzheimer's patient. Okay, so it's not surprising that she got worse over time. In higher numbers is worse scores. But you can see this is a whole year that we followed, the company followed this lady, and you can see that she is deteriorating. So this is very exciting. I think because I have only 5 minutes, I'm not going to get much into it, but I'm just going to say that with a colleague here in Sheba called Meir Plotnik, who is directing all the virtual reality studies, we are trying to transfer paper and pencil cognitive testing into virtual reality. Think about all the advantages of having it 3D. Think of the, right? It's much more a reality check than a paper and a pencil, right? So we have people going into the supermarket in virtual reality, and you have to remember the items that you have to buy there and so on and so forth. So we have initial interesting data, and since I don't have time, I'm going to skip it. And now I'm just going to give a few minutes to the, look here, earliest biological alterations, okay? I emphasize again, we can try to learn the earliest biological alterations. It's going to be awesome. But we will only know if those are the real biological alterations, if they go together with the clinical phenomenology, with the symptoms of the patient. And this is why we want to do both things very, very early. I want to just generally speak, I'm not going to get into the haptoglobin because I think it's going to be too much in this context now. But I do want to say, let me see if I have another slide that is more general, that the direction we're taking is what we call deep phenotyping. We have large samples, 2,500 people that are participating in our studies, and that we're characterizing them with MRI, with PET scan. We take their blood for DNA, we take serum, we take plasma. We obviously characterize them with cognition. We're building into this study novel technologies to see if we grasp changes very early. We characterize them for lifestyle, for diet, for genetics, of course, etc. And part of what we want to do now, or we have begun, I have to say, is to characterize them for their omics. Okay, and I'm going to try to, I'm going to simplistically explain what omics are, and I'm going to tell you that I don't fully understand it myself. Okay, I understand it conceptually, and I think at this point this is all we need. People might know the name genomics, okay? So if once you looked at, you discover one gene or another gene, today you can characterize the whole genome of the human species. You can characterize the whole proteome. Every single protein that has been discovered can be measured in 5 microliter of blood that a person donated for research. The reason why this becomes so exciting and interesting is that we are complex creatures, okay? If we thought once, and these are the majority of those 460 medications that I mentioned before, if we thought once that a particular molecule, a particular protein will make the whole difference, we understand today that this is much more complex, that this is probably pathways, and even pathways that are interacting one with the other, right? If you're familiar, this is the whole a new area of system biology. And the professionals that are the most important ones in this area of system biologists are computational biologists, are people who are able to take 8,000 proteins in 2,500 people and try to tease out what are the groups of proteins that are affecting cognitive decline and dementia. And then instead of looking for one of them and make a medication for that one, we're going to have to understand how do we change the whole complex of that protein. So we have begun working with that. And this is data that in some area, we're probably going to have data or evidence probably in another 6-7 months is going to take us. And then everything else we're trying to put together over the coming years. The other piece that is exciting is that we put all this data up in the cloud. And, we want to be ahead of the curve. We want to discover a cure or a prevention measure for Alzheimer's disease. But more than that, we want someone to discover it because it's a horrible disease. So we put that in the cloud with people who are extremely well characterized, and the world can work with it. Anybody can ask for the data and work with it. So this is the example of what we're doing now, but I'm going to skip it. So I'm just going to finalize with what I always say, a beautiful goal. And you guys might be familiar with Madame Jean-Louise Calment. She died at 122. She was the record at that time. And I believe there is a Japanese lady that made it to 125. But the reason why I love this particular woman is that she fenced until she started fencing when she was 85, and she biked until she was 100, and she smoked 2 cigarettes until she was 117. I always make a point that it was only 2 cigarettes because people say, oh, so smoking is good to get old. And I do always ask myself, why at the age of 117, she decided to stop smoking, which is kind of funny. And she did drink red wine every day. And the one that I personally most love is that she had 2.5 pounds of chocolate every week. That means a pack of chocolate every day. I'm a chocolate lover. But the most important part here is that this lady died at 122 peacefully and with no dementia. She died cognitively intact. So that's it for now. And I'm happy to take questions.
Great. Thank you very much for this presentation. Thank you, especially also for joining us tonight. You gave us many cues and many concepts to think about. And I hope also those who aren't really into the medical field who followed us managed to get a bit more into the world of neurodegenerative diseases, into Alzheimer, because many concepts were kind of clear. And also on top of that, I didn't say it at the beginning, but I want to thank the Keren Kayemeth Italia who helped us make up this live stream, and also gave last year a big donation to the Alzheimer Center in the Sheba Medical Center, and that's how we got in touch. We saw this this amazing initiative that they have done, and we got very interested in the project and in general with this really great center in Israel. And also as a medical student, this presentation was very stimulating for me, especially in the direction of preventive medicine, early diagnosis, which are really game changers in this field. And now I would like to give the word to Giulio, who has already a couple of questions. And in the meanwhile, I'll look on Facebook in the comments to see if there are other questions. And I invite everyone to ask more questions if they're interested here in the comments below. Bye, Giulio.
I'll start with a couple of questions. First, really thanks for this talk. I think it was really good to give an overview of what Alzheimer is, the new research line, and the importance of early prevention. That's really useful for the general public. And also the innovative way of Israel to deal with this type of problem, like the research of virtual reality was really fascinating. I also work in a lab with virtual reality, and I found really it's a good tool. And I have a question regarding possible treatment, because you mentioned that many treatments with normal pharmacological treatment didn't work, while cognitive treatments were able to delay Alzheimer. So the first question is, do you think that the developing of cognitive treatment would be enough to deal with the problem, or we need to find biological marker to really solve the problem? So this is a first question. And
wait, so hold it for me, because I'm not sure I understood the question. So you're going to have to repeat the question for me.
If a cognitive approach to deal with Alzheimer could be an answer to the problem, or we need to find a biological marker or something like that to really treat Alzheimer.
So if a cognitive approach
could alone...
Okay, I got it. And I have something interesting to tell you. Keep going.
And another one regarding the role of big data analysis, because you mentioned how it's important of computational biologists to make a link with different proteins. And so if you think that the future will come from this type of approach, so big data analysis, or with a more classical approach of I don't know, because it's really something new. So I mean, classical lab approach where you have an hypothesis and tests like that, or instead take a big data set and just explore and find an answer.
Mm-hmm. Right. With the first, let me answer the second one, because I'm going to have to be politically correct, mainly because I don't know. Okay. The answer is that I sincerely don't know. We need some luck in the field. All right. I think that what might end up happening is that big data is going to open many, many opportunities that will end up being tested in classical ways. All right. So I think we'll see several pathways, inflammatory pathways, or whatever, long-term potentiation pathways. And then we're going to dig and end up in a particular molecule or a particular protein. I think this is what might end up happening. We don't know yet, just exactly because of what you said, because it's relatively new. And you need, one of the issues with Alzheimer's is what I said throughout the whole presentation. If you have a lot of big data for people who are 50 years old, essentially you're not going to know for 20 years who is going to develop or not going to develop the disease. This is why I'm so eager about those very, very subtle markers for assessment of cognition, because I say, okay, we're not going to see real Alzheimer's disease, but at least we have something measuring some level of very, very subtle decline, suggesting that person is not in a good pathway. So my real answer is I don't know. And I do think that big data is already opening a whole new a perspective, and taking into account that we had so many failures treating amyloid, I think this is a blessing, right? It's an opportunity. With regard to your question, if we could treat cognition through cognition, it's a very interesting question. Probably that would not be enough, although there is a Cochrane review, for example. Cochrane review, for those who are not familiar, it's an institution funded by the British government that has the job of taking clinical trials and writing and doing meta-analysis on those clinical trials and coming with conclusions that help the British government define certain policies. All right. So there is a Cochrane review by a postdoc that was here with us, Alex Bachar, and where he shows that although the effect size of cognitive training, for example, is very tiny, but it's positive, very tiny, when we talk about years and years, may make a difference. But in addition to that, I want to mention something that it's just something that we have begun doing. And so it's going to take a few years until we'll have an answer. But it might be of interest to you in particular, Giulio. I have a PhD candidate. He's not even a student yet. He's a neuropsychologist, hardcore. And he's extremely interested in what we call cognitive reserve. He wants to understand why there are people whose cognition remains very good to the end of their days, while their brain is a mess with a lot of pathology. He wants to know what is subserving good cognition despite a lot of pathology. And his question is strategies of resolving tasks in life. So he thinks that people who are able to activate effective strategies to resolve issues, right? In neuropsychology, it would be to resolve a task, but in real life, it's to resolve our day-to-day life. So people are able to use effective strategies. And when they can't, that they can recruit alternative strategies, he thinks this reflects on neural substrates of cognitive reserve. And that would be something we'll have to show with time.
You really answered my question. And I have other questions, but maybe if there are questions from the public, I want not to steal the stage. So David, do you have any question from others?
So we have a question from the crowd, so that asks, can you measure how ill is how the patient, let's say, how much conscient, how responsive he is, and like mentally present in his dementia? Like, how do you measure it exactly, and how do you do it?
Okay. Do you want to read it to me in Italian? Let's see if I grasp it.
Ecco, si può misurare quanto il malato sia cosciente della sua demenza?
Okay, so I got it.
Like if he's if he's conscious of his
disease. Can we measure how conscious a person is, or how aware a person is of his or her dementia? So I don't think we have ways of measuring how aware a person is, but I can say that the point when a person says, my wife keeps telling me that I don't have a good memory, but I feel that I'm totally fine, that's a very concerning moment for us, okay? So lack of awareness of deficits is a problem, all right? Now, if the question is, if the person is getting, right? So many times the person said, no, I don't think I have any problems with memory, while the family members believe the person has. And then there are those fluctuations where the person becomes aware. There is a lot of sadness and depression when people understand that they have a memory impairment, that they might be deteriorating. And as time passes, the disease stops being the patient's disease and becomes the family, because the patient does lose the capacity of understanding, of being aware of his or her limitations, while the family is, accompanying the deterioration. So I hope I answered.
Thank you. And now we have also another question from Julia, and she says, I've heard many times that being mentally active, for example, doing memory exercises, reading, delays the development of Alzheimer's disease. Do you know if there is any scientific evidence in support of this?
So the answer is yes and no. The yes is that if you look at the epidemiological studies, observational studies, large-scale studies, and they look at people who have intellectually triggering leisure activities like playing chess or playing whatever, poker or whatever, something that makes them think and quantify, etc. Those people have a lower risk of developing Alzheimer's disease over time. So that makes us think that people, even after you adjust for socioeconomic status, for the number of years of education, people who play sophisticated games, they'll tend to be more highly educated, more intelligent, etc. So even if you adjust for that, still having that cognitive activity is associated with protection. The reason why I said yes and no is before I told Giulio that this Cochrane review was looking at clinical trials that compare people who received cognitive training to people who received some video games or something more passive. And there is a little bit of data showing that, not a little bit of data, that if you put all those studies together, those who received cognitive training seem to be doing a little bit better. I do want to mention something. It's just that I don't see you guys, so I'm not sure if you're reacting or not, but I'm going to assume you are. That one of the major problems in the clinical trials of cognitive training, which would respond Julia's question, is that most often we use a group that is the group receiving cognitive training and a group that is receiving a some other control, like playing games or receiving classes in education about health. And most often they don't have a third group, which is a completely passive group. What do you mean by that? A group that you measure their cognition at baseline, and you measure their cognition 3 months later, 6 months later, whenever the other groups were receiving intervention. Why is that passive group so critical? Giulio, do you have a thought? Why the passive group is so critical? Because you have a thought, or I'm putting you against the corner?
No, I know, because you don't know if the effect is driven by time or other factors that can... Learning.
You do a test, you do cognitive tests at baseline. You come back, you do tests 3 months later, you have some clue of what that test was, and you do better. So you need, for us to know if that little increase that the person had because of cognitive training is not solely the learning effect. Yeah, so this is one of the problems. So to finalize the answer to Julia is, my recommendation when I talk to older adults is, you can only gain from it. Get out, I say, sweat your brain and get out of your comfort zone. Now, to say in the sense that, right, I said before, I'm learning Italian now. It's very important to me. It's a language I love. And I'm doing it among many reasons because I want to get out of my comfort zone and I want to do something that is effortful for me, that it's effortful for my mind. So the epidemiological studies support it. The clinical trials are too weak for me to say, yeah, it's a bang, but the direction is the right direction. There is nothing for you to lose, and therefore I would recommend.
Great, thank you very much for the answer, also for this one. And I think now instead Giulio will want to ask another question.
Maybe I thought something useful for the general public is what to do if I have a relative that is affected by Alzheimer.
Okay, this is actually not a trivial question at all. And I am going to say something that some expertises will be pissed with me, but I'm going to say it out and loud. Do not take your patient, your family member, your loved ones to a general practitioner, to a family member, doctor, to an internist. Take them to a specialist, all right? The idea that diagnosing Alzheimer's disease is super simple because if the person is forgetful, that's the reason, is a mistake. And it could be different types of dementia, and it could be some differential diagnosis, it could be many things. And also the specialists are going to be connected to other specialists that might give an answer if there is something different that is happening in the brain, or if there is something different that is happening in the course of that loved one. So my recommendation, out and loud, if you feel that your loved one is developing something, the earlier the better. There is some literature on the medication, the 4 medications that already exist, that if you bring your patient in the beginning, you have a better chance to hold him a little longer feeling okay, and to go to a specialist in Alzheimer's disease or to memory clinics rather than going to the general practitioner.
Okay, David, do you have also some questions? Because
yeah, I have like a final question, since also from the public on Facebook, we don't have other questions. I wanted to ask this. So basically, you work together with the Sheba Medical Center, who also recently has been ranked in the top 10 center in the world, medical center.
Three times in a
row. 3
times
in a row, so even better. So yeah, the main question is, like, what's so special about it? Like, what did you do to arrive to this like high ranking? And also the second question is, what could, like, Israel has always been like a great opportunities for Jews from all around the world. So for medical students, in general, scientists out there that are here in Italy that are following us, what also are the opportunity that the Sheba Medical Center are offering for young Jews throughout the world?
So it's easy for me to answer the first question, less so the second, simply because I'm not sure, all right? I can tell you that let me answer this, what I do know about the second, because it's a more limited answer. I can tell you that in our center, we have people coming from everywhere, including non-Jewish students, okay? So I have We have students coming from Germany. I haven't had an Italian yet. We would love to. United States, plenty. South America, I got a few. France, we have a PhD student with us now that is staying with us, and she's spectacular, and so on. And I know that when you go in the corridors, you hear almost every language, like you do in Israel in general, but in the hospital in particular. So I believe we have a lot of openness to bring good students into the country. There are a few international programs, but I'm not well knowledgeable about them. I know there are a few medical school programs between Sheba and other medical schools around the world, but that's something I wouldn't know to say in detail. With regard to why I think we received 3 years in a row one of the 10 best hospitals in the world, I think it's a combination of many things. By the way, the number one reason for the ranking is because of our research, okay? Because of Sheba's research and development. And in that sense, I think we do very well, okay? We get many grants, including European Union, including National Institutes of Health, local grants, and you get grants, those kind of competitive grants you get because you bring good ideas that are competitive. I always say, people say that Israelis think out of the box, and I say that's a misconception. Israelis have no box. All right, there is no box in this country, and in the hospital you feel it very, very strong. Okay, many questions, many research opportunities that come from just courageous and limitless curiosity. So I am a mentor both in Israel and the United States, and I love doing it in both countries, and I love connecting between my students in both countries because the typical way of work is very, very different. Okay, my American students tend to be extremely well disciplined, but they'll tend to come and say, "What do you think about this? How do you like this idea?" And my Israeli students knock the door and say, "We have to do this idea." Right? They come and they have the idea that they want to do, and much of my job here is to do some screening and due diligence of the gazillion ideas that people come with, and they have to decide this is a good target, this isn't. So research, by all means, here in Sheba is I want to say it, and I'm going to say it with some lack of humbleness. There is no other hospital in Israel that compares in any level to our level of research, in any level, in any of the fields. The hospital, Hadassah does very well in certain areas and other hospitals, but nothing compares to what we do. The other thing is the care. If you guys had been here, and I'm sure, Milano for sure was hit so bad, but the care, there is something very impersonal and very non-formal in the Israeli culture. And seeing a doctor crying next to a patient is not an unusual thing to see, and I feel emotional when I say it. So there is something in the lack of formality that allows, again, this lack of limits in giving. So I think that makes a good service. And I think those probably are the two big ones. I'm trying to think if there is, again, about research, I know so much, and about the clinic, I see enough. And maybe something that is more general to Israel, the whole issue of novel technologies is something this country has no fear of. There is no one older adult in the country. It can be in Tzfat, it can be in Eilat. A 90 years old will know to maneuver their WhatsApps, and they won't ask questions. In the US, I can't get my colleagues to use WhatsApp. And here it just goes without saying. So there is no fear of technology, and people use it. And this hospital is washed with novel technologies. So I think those are the main reasons.
Yeah, they sound really amazing, especially this focus, let's say, on the Israeli society, Israeli mentality, which we always admire, especially for this informality and, let's say, being direct with the patient, you know, instead of being too detached or too much formal or too much focused on the, let's say, on the medical on the medical symptoms rather than the empathy, you know, the personal relation with the patient. So yeah, I think that right now we can start to go towards a conclusion. It has been a really nice presentation, and I hope everybody at home enjoyed it very much as well. And they had this amazing opportunity of having the Professor Beeri here with us, and who I thank very much again. Thank you so much for being with us at this late hour. We know that in Israel it's even later, so it must have been a very long day for you. And also thank you to Giulio for helping me and joining us, asking some insightful questions. And I don't know if you want to say just last goodbye to everyone.
Yes, goodbye to everyone. And thanks to
How do we say goodbye to everyone in Italian?
Arrivederci e buona serata.
I know how to say buonanotte, right? There is a buonanotte.
Yes.
Yeah, but later on, it's the night is young.
That's buonanotte for me already.
Yes, thanks to the professor and David for this opportunity. And I think, can I invite the guests to write you if they have future questions? I think.
Sure, pleasure.
And that's it.
Very good. So I'm going to go. Thank you so much. Thank you for having me.
Arrivederci a tutti. Ciao. Grazie di essere stati con noi. Bye bye.